Hello, mathletes. Today we're going to be doing our lesson on dilations, which is the fourth transformation that we have to know. So if you remember, our other ones were translation, which is the slide, the rotation, which is turning around the origin, reflection, which is the flip or the mirror image on the coordinate plane, and then dilations, which is like your eyeball at the eye doctor, where your pupil gets really big or really small depending on the light. So if you look here, I've given you an example. The purple shape is the original and the new shape is the green. So if you looked at that, you would know that it's a dilation that's greater than 1. And if we looked at the point of point C, which is 2, 1, and the new points would be at 4, 2, I could deduce or figure out that I'm multiplying by 2, so it's going to be 2 times bigger. Our learning target hasn't changed. We're still, when given a polygon or shape on the coordinate plane, will represent a transformation, either a reflection, flip, dilation, grow or shrink, rotation, a turn, or a translation or slide by graphing it on the coordinate plane. So break out your notes. We are going to dive in and it won't take us very long. A dilation is a transformation where the size of the figure is multiplied by a scale factor. And you've heard scale factor before. We talked about scale factor when we did proportions and similar figures. And we just talked about scale factor when we did our last unit and we talked about quadrilaterals and totally blanked and can't remember what our test was on last time. Anyway, a scale factor is just simply that factor or that number we're multiplying by. So if it is greater than 1, guess what's going to happen? If it's 2, 3, 4, the number or the shape is going to get larger or bigger. It's going to grow. And likewise, if the scale factor is smaller than 1 or a fraction, so we could do a half, we could do a fourth, we could even do an eighth or something like that. If we do that, though, you're going to want to turn these into decimal points and multiply by the decimals in your calculator. And that will result in a shape that is smaller or shrinking. So if it's greater than 1, the shape gets bigger. If it's smaller, the shape's going to shrink. So it's pretty simple. If you look and you see a big shape, you can guess that it's probably going to get smaller. If you see a small shape, it's probably going to be growing or getting bigger. Okay, so all we do to dilate a figure is you're going to multiply each number in the ordered pair by the scale factor. For example, if you look here, we have -4 and 6. That's our x and our y values in our ordered pair. And we're going to multiply it times a scale factor of 1/2, which we want to change into a decimal, which is 0.5. So if I take half of 4, that's going to give me -2. Negative times a positive is still a negative. Half of 6 is 3. So that's all we did. We took 4 and 6 and divided it by 2 or multiplied by 0.5. Likewise, if we're multiplying by a scale factor of 2, we're just going to take the x value of 2. We're looking at this one. 2 times 2 is 4. -1 times 2 is a -2. If you plug these in your calculator, it'll do the work for you. But if you want to remember your integer rules, just remember we went back, do your tic-tac-toe board where you have positives going diagonally and everything else is negative. Remember these from your integer rules? So if I did that, I have a negative times a positive, which is this one right here. Negative times a positive still gives me a negative, so I know that my answer there has to be negative. Okay, so let's look at our example here. Our original points For the R is -2, 1. S is at -3, 0. T is at -3, 2. U is at -1, 2. And V is at -1, 0. Now, I'm multiplying by a scale factor of 2, which means I'm just simply going to take each of these numbers and multiply them by 2. So a -2 times a +2 is going to give me a -4. 1 times 2 is 2. -3 times 2 is a -6. 0 times 2 is still 0. -3 times 2, again, is -6. 2 times 2 is 4. -1 times 2 is a -2. And then 2 times 2 is 4. -1 times 2 is a -2. And 0 times 2 is still 0. Now all we have to do is graph it. So if we go to a -4 and then go up to, whoops. Okay, so this is our new R. And -6, 0 is here. And that is our new S. T is at -6, 4. So here's our new T. I'm going to have to erase that R. I think it's going to be in the middle. So here's what our shape looks like so far. And then our new U is at -2, 4. That's our new U. And our new V is at -2, 0. So you can see not only when we dilate the shape, this is our R, not only when we dilate the shape does it grow or shrink in size, but it also slightly moves on the coordinate plane. That's just how it works when you're multiplying the numbers. Go ahead and pause the video if you want to make sure you have that graphed correctly and make sure you get your points. I'm going to go ahead and move on just for the sake of time. All right, on the next page, this one is split in half, and I'm working on the left side first. Again, we're doing it by a scale factor of 2. So if we look, I've already given you guys your original points are here, and we're multiplying those by a scale factor of 2. So simply take each point and multiply it by 2. 2 times 2 is 4. 1 times 2 is 2. 4 times 2 is 8. 1 times 2 is 2. 2 times 2 is 4. -3 times 2 is a -6. 4 times 2 is 8. -3 times 2 is -6. And all we have to do is graph it. So let's go over to -4, which is here. You can't see it. And then up to, that is our new A. We're going to go over 8 and up to. That is our new B, or B prime. C is over 4 and down 6. And then D is going to be over 8 and down 6. And it just forms another rectangle. That's over slightly, but you can see it's twice as big. So multiplying by a whole number causes the image to get bigger. Or grow. You can put grow there too. And we multiplied by a scale factor of 2. Again, if you need more time, pause the video, make sure you have it all copied. This is on the second half of that same page. Now we're going to be multiplying by a scale factor of 1/2. So I'm going to change that to 0.5. Remember, that's the same as 1/2. So I'm going to multiply each of these by 0.5 or 1/2. I can also ask myself, what is half of this number? And that's another way to do it. So what is half of -10? And that's going to be -5. Half of 10, 5. Or if I use my calculator, you can just simply take the number times 0.5. or divide by 2. That will work too. You can do either one. Half of negative 4 is negative 2. Half of 10 again is 5. Half of negative 10 is negative 5. Half of 2 is 1. Half of negative 4 is negative 2. And half of 2 is 1. So now all I have to do is graph it. I'm going to go to negative 5, 5, 1, 2, 3, 4, 5. It's going to be right about there. You can't see it because the shape, but that's our new A. We're going to go to negative 2, 5, which is here. We're going to go to negative 5, 1, which is here. That's our new C, C prime. And negative 2, 1, which is our D prime. And then all you have to do is connect them. And if you can see from our original shape to our new one, how much smaller it is, it's shrunk. If I put that in there, it actually looks like it is a fourth of the size, but it's a little bit more than a fourth. Because remember, you're taking half of every single point, so it becomes actually a little bit more. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, yeah. It's a little bit more than half, or a little bit more than a fourth. Okay, so multiplying by a fraction or a number less than 1 causes the image to get smaller, or you can put in parentheses, causes it to shrink. Okay, and that is all of our notes in a nutshell. Just remember, if I'm multiplying by a whole number, like a 2, a 3, a 4, the number or the shape's going to get a lot bigger. If I'm multiplying by a scale factor that is less than 1, like a half or a fourth or even a fifth, which is really small, you can simply take the number and divide it in your calculator by the decimal, and it's going to make the shape shrink. Don't forget to do your homework and make sure you have your notes completed for full credit.